All right, here on the left of the screen is our assignment for making this cam working drawing. No picture, you notice. And he gives you some information, including the base circle is a diameter of 2 inches. The shaft, the hole in there, is 5/8. The roller is 3/4 and some other stuff. All right, so let's look at that base circle here. That base circle that he says is a diameter of 2 inches or a radius of 1 inch. That's the distance from the center of the shaft up to where the follower hits. And then it's another, because it's a 3/4 inch roller, it's another 3/8 of an inch up to the middle of the roller. So 3/4 inch diameter or 3/8 inch radius. So from the center of the camshaft to the center of the roller is 1 3/8. Let me expand this slide thing here. So from the center of the camshaft to the center of the roller is 1 3/8. That means that the radius of your prime circle, the one you'll be working with, is a radius of 1 3/8. And remember that number. This will be the first number in your table that you put on your drawing. So when the roller is at 0 degrees, that radial distance will be 1 3/8. All right, here is the squished up version of our displacement diagram. And looking at this, we see that we have lines every 30 degrees from 0 over to 210, and then from 330 to 360. So 330 all the way to 210, we have lines every 30 degrees. And then in between 210 and 330, we have lines every 20 degrees. So what? So we'll draw radial lines in a circle around the center of our cam, and we'll start at, well, really you could think of it as from 330 all the way around to 210, you'll have a line every 30 degrees. And then from 210 around to 330, you'll have a line every 20 degrees. And you could put those in by whatever method you like to use, from slow to fast. I'm kind of middle. I'm not good with array, but I can use rotate. We'll look at that when we go look at our CAD drawing. Okay, now, here's your drawing with some radial lines spraying out from the center of your camshaft. Let's look at the line that goes at 30 degrees. If you look at your displacement diagram, you can measure at the 30 degree line, you can measure the height from the bottom line up to your graph line. And you will find out that it happens to be 0.407. That's just the length it is. What that means is that your next follower will be centered 0.407 out beyond the prime circle. If you want to think about what is the radial distance from the center of the shaft all the way out there, that distance is the prime circle, 1 3/8 radius, plus the 0.407 you just found. So that distance, that radial distance from the center all the way out, totals 1.782. It's 1 3/8 plus the 0.407 height, 1.782. And that is the number that you enter in the table on your drawing under the 30 degree angle. Backing up a minute, so this is our 30 degree line. At 30 degrees from the center of the shaft out to the end of that thing, where we're going to put a follower, is 1.782. So we put that into our table. Look here. Here is that radial distance we mentioned at the start of these slides. At the 0 point, when the follower is, in its lowest position, from the center of the shaft to the center of the follower, that radial distance is 1 3/8. In other words, the radius of our prime circle. Here in the 30-degree position is that next number we just found by looking at the height of our graph. Now we'll go on to the 60-degree position. And in CAD, if you measure the height there, you'll find out that happens to be 0.953 from the bottom of the graph up to where that graph line is. That means on this 60-degree line, it's 0.953 beyond the prime circle, out to where you'll have another follower centered. What is the distance from the very center out to that end point? Our prime circle has a radius of 1 3/8 plus that 0.953 height we just found equals 2.328. And so that's the number you'll plug into your graph there. That was, let me back up, at your 60-degree line. That's how far a distance out beyond the prime circle. And you looked at your displacement diagram where it has a 60-degree line and you measured that height. That's how far out there you're going to go. Radius of the prime circle is 1 3/8 plus another 0.953 takes us out to 2.328. And so that's the number you enter in your table for the radial distance at that 60-degree mark. And at this point, I want to stop and just say something. You might be tired of hearing me say this, and if so, I apologize. But when I am in a design class like this one, and I get some new subject like we are doing with the cams, where we're going back and forth with numbers and adding and this and that and the other, because I have slow processing speed, this kind of class is very hard for me. And in fact, I can guarantee I won't know what's going on. I can't track it, I can't follow it, and I don't know what's happening. And I've been that way my whole life. There's nothing I can do about it, apparently. So what I do is I keep all the resources I can possibly get. Like I'll save the PowerPoint slides, I'll watch the videos, I'll get a piece of paper and I'll write notes about this. And then I use the PowerPoint slide and the video as a kind of a cookbook. And I just try to walk through these things step by step. And at first, I don't know why I'm doing that step. I have no idea what that step is. I just know that that's the next thing on the slide, and so I do it. That's all. And eventually, after I've done this same design over and over a few times, it begins to come into focus, and I know why we're doing these numbers. And the reason for telling you all this is just to assure you that if this seems confusing to you, I don't know what your reason is. Might just be that it's new material. Don't feel bad. It's perfectly fine. Just use whatever strategies you can to help you do the steps. When you do the steps more than once, it will get slightly more familiar each time. It's going to be fine. I promise you it's going to get better. Okay, end of sermon. All right. So anyhow, we have been drawing these radial lines at certain angles and then moving out these distances that we measured from our displacement diagram, and at the end of each of those distance lines we put a 3/4 inch roller. The center of the roller is at the end of that line, and you can see how the rollers are getting farther away from the center each time. Notice that for purposes of drawing the cam, once you get these all laid out, notice that where the cam hits the roller is not the same place as where that radial line intersects the roller. And you can especially see it in this roller over here on the left, sort of in the middle. See here where the cam is tangent to the follower, that's quite far away from where the radial line intersects the follower. The point for saying that is that you cannot snap your spline intersect, it won't be the right shape. You need to snap your spline at tangent, tangent, tangent. And as we said last time, you will need 4 separate lines because you'll have a circular arc at the 2 places where you have dwell. And I will just point out that there are 2 things that are annoying. One, it's too lumpy, especially here in the top of the cam where we have that little circular arc and the little dwell. There's a little divot, a little valley there that is not smooth, and that I don't like that. You won't like it either. It's because we don't have enough radial divisions in our diagram, so we're not precise enough. This is just kind of a rough cut, so it'll be okay. Then the other thing is there are at least 2 places, and I think they're over here on the right, where I have not been able to get that tangent line to work right. It overlaps the follower. I can't get a perfect tangent. Maybe you can, but if you can't, I don't know what to do about that other than to say, this is a rough version of this cam. We don't have enough division lines. Don't worry about it. Okay, and then as we said last time, you'll put an A angular dimension on your front view, and you'll put an R radial distance on your front view with an A degree and an R, and you'll label those rows in your homemade table on your drawing. As we said before, you'll give a keyway depth and depth tolerance. You'll give a keyway width and width tolerance. You'll have this table with the numbers in it and some notes. And I guess this is repetitive. Yes, dwell is circular. And yes, it's a separate line. We said that. And as we said in the previous set of slides, you will wind up with 4 separate lines, and they should look a shape about like this when you're done.